Morning everybody, Richard Beersinger here with another video. There's a lot of effort being spent on how to leverage the power of AI. One area of focus is how to use large language models to answer questions relating to your own specific data. So today we'll dive into the process of fine-tuning an OpenAI model with your own custom data. And since I'm a HashiCorp ambassador here in New Zealand, we'll use Terraform to manage the fine-tuning process. If this sounds interesting to you, stick around and let's get into it. Right, there's a fair bit going on in this session, so I'll break this down into 4 sections. I'll put placeholders in the timeline so you can jump to any areas that interest you. First, we'll start by understanding why you might want to add your own data to AI services. And then we'll take a look at a couple of supported ways you can add data to your AI applications. Finally, we'll check out why you want to use Terraform to manage their OpenAI resources to ensure we keep things under good management and control our costs. And to bring it all to life, we'll do a quick demo of fine-tuning a model using Terraform. All the source code and tools used in this video are linked in the description below and available on GitHub, so you can try this yourself if you want. Okay, so let's get started with the why. Customizing AI models with your own data can be useful for many use cases. By incorporating your own data, you can tune a model to better understand and generate content specific to your domain. This is particularly useful if you work in a specialized field or have a specific data set that is relevant to your needs. Training the model with your own data allows it to learn from examples that are directly relevant to your use case. Usually, this means more accurate responses since the model has a better understanding of your domain. Other possibilities might be to tweak the model to generate content that aligns with your organization's branding, style, or guidelines. We also can't avoid talking about one of the big concerns at the moment, which is data security. In some cases, you may have sensitive or proprietary data that you want to keep within your organization. By customizing the model with your own data, you can ensure that information remains within your control and is not exposed to external systems via the generic models. Okay, so now let's look at how we can add data to these models. There are a number of methods that can be used to augment AI applications with your own data. OpenAI provides a few different ways to do this, but there are 2 main approaches. The first is called fine-tuning, and the second is using embeddings. And there are pros and cons to both approaches, and this could be a whole video on its own for sure. To give a brief summary, fine-tuning involves training the entire model on a specific task or domain and creating a new custom model that's fine-tuned with your data. Embeddings focuses on supplying the current model with some contextual data that allows the existing model to gain additional information to apply to a given request. The way I like to think about this is that embeddings are useful when you want to give the model some additional data it doesn't have, such as data from the last week or latest sales information. Fine-tuning is beneficial when you have a large source of data that you want to create a customized model for task-specific use cases. Typically, the generic model don't know how to answer those sorts of questions. Examples of this might be how to answer support questions on your product or how to classify a given message into some so specialized terms like medical or engineering terms. Okay, so we've covered the why and the how. Now let's consider how HashiCorp's Terraform can help us automate the process of fine-tuning a model. First, if you're new to Terraform at a very high level, Terraform developed by HashiCorp is an open source infrastructure as code tool. It allows you to define and provision your infrastructure resources using declarative configuration files. So why do we need infrastructure as code to manage fine-tuning models on OpenAI's platform? It's likely that if you're going to the effort of creating custom models, you will have fairly complex data pipelines and you will be iterating often to fine-tune your models. This requires the creation of resources, and keeping control of those resources will help manage sprawl and cost. To understand the process, let's run through a basic typical fine-tuning workflow. The process begins with a data set which is specific to a task or domain you want to fine-tune for. This data is essential to train the model further. The data goes through pre-processing and feature engineering steps to to transform and prepare it for the fine-tuning process. This may involve tasks like data cleaning, normalization, or feature extraction or augmentation. In this step, you can select the base model you want to use for fine-tuning and also configure hyperparameters to configure the final model behavior. The prepared data is used to fine-tune the model. This involves taking the model and updating its parameters using the fine-tuning data. This is where the model is adapted to specific characteristics of the target task or domain. Finally, the fine-tuned model is evaluated using validation or test data sets. This evaluation helps assess the model's performance using metrics like accuracy, loss, or analysis of the behavior on the specific task or domain. Based on the evaluation results and performance analysis, iterative improvements can be made to enhance the model further. This may involve adjusting hyperparameters, modifying the fine-tuning dataset, or experimenting with different base models. These steps in the process here require calling OpenAI's APIs to upload data and initiate the fine-tuning. OpenAI queues up the job, and when resources are available, your custom model is created by fine-tuning an existing model. By the way, interesting point to note here is that you can continually fine-tune an existing fine-tuned model, which might be a way to iteratively improve the performance of your model. Once OpenAI completes the fine-tuning job, a number of resources are created, such as the new fine-tuned model and some results data. As mentioned, the process of fine-tuning a model in OpenAI typically involves multiple iterations where the model is refined and improved gradually. This iterative approach allows for continuous experimentation and fine-tuning until the desired performance is achieved. And this iteration is why we're going to automate using Terraform. As is common these days in cloud, you pay for what you use, so you want to keep track of these resources and clean up as needed. This is precisely what Terraform is designed to do, and why I can see organizations wanting to use Terraform to manage this process. Okay, let's jump into the demo and see this in action. For the demo, we're going to use a sample cookbook for fine-tuning as provided in this OpenAI cookbook on GitHub. Again, this is linked below, so feel free to take a look for more detail. In this example, OpenAI creates a fine-tuned model by training a custom model to classify messages as either relating to baseball or hockey. The scenario involves training a fine-tuned model on a bunch of newsgroup posts, about 1,200, split evenly between hockey and baseball. I'm going to start from a clean sheet so we can get an idea of how simple this is. I have a repo on my GitHub that contains this demo. Again, reminder, link is below. So first I'm going to clone the repo. I'm going to open this folder in VS Code so we can see things more easily. There are two folders. The first folder contains a Python script we can use to test our fine-tuned model. We'll come back to this after the model has been created to give it a try. The second folder contains the Terraform used to manage the fine-tuning process given some pre-processed data. Let's take a look at the pre-processed data now and the validation data. Okay, this is the main Terraform configuration file. You can see that the top section here requires the skyscraper Terraform provider for OpenAI. Next, we create an OpenAI file resource for the training data and another file resource for the validation data. And here we have the main OpenAI fine-tuning resource that has some configuration and references the training and validation data mentioned above. Finally, we can see that we output the custom fine-tuned model we've created so that we can use it in downstream processes. Before we can run Terraform, we need OpenAI API keys to be able to access the OpenAI APIs. I'm going to create an API key for this demo. Don't worry, I'll delete the key before publishing the video. We can configure the Terraform provider for OpenAI by setting this environment variable to our API key. Okay, let's start by running Terraform init. This will install the necessary Terraform components, including the Skyscraper Terraform provider for OpenAI, from the Terraform registry. Okay, now we can run Terraform plan. This will produce a plan explaining what will be created. Here you can see that it's a total of 3 resources. An OpenAI file resource for the training data, another OpenAI file resource for the validation data, and then the fine-tuning job to tune a new model using the supplied data. Okay, so we're happy with the plan. Let's apply the configuration. This process can take a while as it waits for OpenAI to queue up the job. So I'm going to add this logging environment variable to my command so we get stream progress information. Okay, Terraform asks us to confirm if we're sure we want to go ahead. We're definitely happy to do that, so let's enter yes and let's go. And just like that, we are fine-tuning. Okay, the delay here can be minutes or hours, so I'm going to speed up the video here. Okay, so we have successfully completed the fine-tuning job. It took a total of 3 hours and 47 minutes. Here is the output from the Terraform configuration with the ID of our customized model. Now let's try using the model. For this, I created a very simple Python script that will use the new model. I'm specifying the model here, and we are passing the content of a tweet for the model to categorize. I'm going to start by creating a Python virtual environment. I'm then going to activate the environment and install the OpenAI dependency. Right, now we should be able to run the app. And there we go, the model has classified the tweet as relating to hockey. Okay, let's say we are done and need to clean up. We can now run terraform destroy and this will remove the resources. It's that simple. The destroy process will remove all the resources associated with the fine-tuned model and avoid any unnecessary long-term costs. Alright, congratulations, you've learned the basic steps involved in fine-tuning an OpenAI model with custom data. Remember, fine-tuning allows you to leverage the power of pre-trained models while adapting them to your specific needs. With the right data, base model, and careful fine-tuning, you can create powerful AI models tailored to solve your unique problems. That wraps up today's video. I hope you found this tutorial helpful. If you've got any questions or suggestions, please put them in the comments below, and I'll catch you next time.